In the unforgiving winters of 1203 and 1204, as historical records attest, a baffling phenomenon defied all reason. While Crusader armies, sheltered within their supposedly impregnable stone fortresses, succumbed to the bitter cold, local populations, employing age-old Scandinavian building methods, not only survived but thrived in the very conditions that proved fatal to seasoned warriors. Yet, the most astounding revelation for researchers lay in the fact that these rudimentary wooden structures weren't merely withstanding the frigid temperatures. They were, incredibly, becoming more effective as the cold intensified, while the advanced stone castles were, in effect, turning against their occupants. Prepare to reconsider everything you believe about medieval architecture. The secret? The Vikings had unlocked principles of thermal engineering that continue to perplex modern scientists. And the most remarkable discoveries remained hidden beneath layers of earth and time, awaiting unearthing to reveal a level of technological sophistication that would necessitate a complete rewriting of the history of medieval engineering. The excavations at the Borg Museum in Norway commenced as routine archaeological investigations. But then the thermal imaging data arrived and everything shifted. Preserved timber from Viking longhouses displayed insulation capabilities surpassing those of contemporary materials. However, that was merely the tip of the iceberg. Uppsala University's analysis uncovered something so extraordinary that researchers questioned the accuracy of their equipment. These structures weren't just adequately insulated. They were conceived as comprehensive thermal management systems, employing principles that weren't formally recognized until the 20th century. Every beam, every joint, every material selection adhered to engineering concepts that are now considered cutting-edge by modern passive house architects. Reconstruction experiments at the Lofoter Viking Museum substantiated the theory. Interior temperatures soared 40 to 50 degrees Fahrenheit above the outside air, while consuming 75% less fuel than traditional medieval heating methods. The Vikings had attained a level of thermal efficiency that even contemporary sustainable building designers struggle to replicate. But the timber itself was only the beginning. What researchers unearthed next shattered material scientists' preconceived notions about wood. Archaeological analysis from Hedeby revealed that the Vikings weren't simply utilizing readily available timber, they were engineering it, much like modern material scientists. Dendrochronology studies demonstrated that they meticulously selected specific trees from harsh climates, where survival against brutal conditions yielded dense, resin-rich cellular structures. Then came the preparation process, which sounds almost implausible. Cold seasoning, involving soaking strip timber in near-freezing water for entire winters. Modern materials testing has validated this ancient technique. Cold water treatment enhances thermal resistance by up to 30% compared to conventional drying methods. Here's the component that truly baffles engineers. This treated timber actually becomes more effective as temperatures plummet. The cellular structure contracts, creating tighter thermal barriers, meaning Viking buildings became more energy efficient the colder it became, a phenomenon precisely the opposite of modern materials. Reconstruction experiments at the Viking Ship Museum corroborated this. Walls that sealed themselves tighter as winter's grip intensified. But timber preparation was child's play compared to what followed. Ground-penetrating radar recently uncovered something that has HVAC engineers questioning their very profession. Ground-penetrating radar surveys of Viking sites have revealed intricate networks of channels beneath longhouse floors, sophisticated heat distribution systems that HVAC engineers recognize as even more advanced than most contemporary designs. The central hearth acted as a precision-engineered thermal battery. Carefully arranged stones absorbed heat during burning and then radiated it for up to 12 hours after the fires had died down. But the real brilliance lay concealed. Warm air was channeled through floor spaces and wall cavities, creating the first documented radiant heating system in Northern Europe. The University of Bergen's testing facility validated these findings. These passive systems could sustain human life at -40 degrees Fahrenheit with minimal fuel consumption. They had achieved what modern green building calls thermal zoning, a millennium before the concept even existed. Yet even this engineering marvel paled in comparison to what came next. What archaeologists found in the roofs will make your smart home look like a Stone Age cave. Archaeological analysis at Trelleborg uncovered something truly extraordinary. Automatic ventilation systems integrated into the roof structures that opened and closed based on temperature and pressure, requiring no human intervention. These weren't crude openings, but rather precision climate control mechanisms. Increasing temperatures expanded the air, opening ventilation channels and preventing dangerous overheating. Extreme cold contracted the air, sealing the passages and conserving precious heat. The buildings essentially operated themselves. Experiments at Denmark's Living History Center demonstrated the system's effectiveness. Perfect carbon monoxide prevention while maintaining optimal humidity levels. Excessive moisture would freeze within the walls and destroy the insulation. Too little would create fire hazards and respiratory problems. The archaeological record indicates that Viking communities, sealed inside during the worst storms, maintained safe conditions for weeks on end. The buildings had become autonomous survival machines. However, the most shocking discovery was yet to come. The feature that distinguished these structures from every other medieval shelter addressed winter's deadliest threat, and it wasn't what you might expect. Excavations at Jarlshof revealed that the Vikings had engineered their houses to create multiple climate zones, the first integrated refrigeration system in medieval Europe. Areas near the hearth remained warm for living. Middle zones maintained perfect food storage temperatures. Peripheral areas stayed cold enough to preserve meat without spoilage. Isotope analysis of preserved organic materials reveals sophisticated fermentation techniques that didn't just keep food edible through the winter. They enhanced its nutritional value over time. The Vikings had created complete survival ecosystems within their wooden walls. These systems sustained entire communities through months of winter isolation. But here's the part that will truly blow your mind. None of this revolutionary technology would have functioned without the most critical element that separated successful Viking settlements from those that failed. Archaeological evidence reveals that operating these systems required a level of knowledge more complex than modern engineering manuals. Every member of the community had life-or-death responsibilities, maintaining thermal systems, managing food preservation, and monitoring building performance. Children learned thermal management through formal apprenticeships as rigorous as weapon training. Runic inscriptions suggest that this survival knowledge was preserved through multiple systems, oral traditions, practical training, and even carved technical manuals. The precision was absolute. One mistake could kill entire communities within hours. This created a knowledge preservation system more accurate than modern technical documentation. Comparative studies across Viking regions demonstrate remarkably consistent techniques, proving that successful methods were shared through sophisticated networks spanning thousands of miles. But there was one final revelation that changes everything. This discovery is why modern engineers are desperately trying to recreate 1,000-year-old technology. Today's most advanced facilities, Antarctic stations, military Arctic bases, and sustainable buildings all employ principles that the Vikings perfected a millennium ago. The passive house movement studies reconstructed longhouses to understand how to achieve maximum efficiency with minimal energy input. Military survival training now incorporates techniques validated through Viking archaeology. Technological shelters apply thermal principles first documented in medieval Scandinavian settlements. Here's the shocking truth that modern engineering is rediscovering. Effective survival isn't about overpowering conditions with energy-intensive systems. It's about adaptations so perfect that environmental extremes become advantages. The Vikings optimized for resilience and efficiency under resource constraints. We optimize for convenience, with abundant energy. But when the grid fails, guess which approach keeps people alive? Climate researchers studying historical adaptation call Viking techniques successful human adaptation to extreme conditions using sustainable methods. In other words, they solved problems we're still struggling with. Archaeological research reveals engineering principles that remain crucial today: redundant systems, passive efficiency, local materials, and integrated functionality. Human construction fails when external energy disappears. Viking techniques created resilient systems functioning independently of external resources. Emergency preparedness experts increasingly recognize this as essential for climate resilience. The lesson isn't about superior ancient technology, it's about different priorities. The Vikings engineered for survival when everything else failed. As building researchers conclude, these medieval techniques offer validated solutions for contemporary challenges. How do you create shelter that works when modern infrastructure doesn't? The answer was buried in frozen ground for centuries, waiting for us to rediscover that sometimes the most advanced solutions aren't the newest. They're the most thoroughly tested by survival necessity.
Think about this.
Right now, you're probably sitting in a building that would become uninhabitable within hours if the power failed. Meanwhile, archaeological evidence proves that our ancestors created thermal management systems that sustained communities through conditions that would challenge our most advanced technology, using nothing but wood, stone, and brilliant engineering. The Vikings didn't just survive winter. They mastered it so completely that their solutions are being studied by modern engineers trying to solve the same problems with vastly superior resources. They prove that true engineering genius isn't about having the best technology. It's about understanding the problem so deeply that your solution becomes unbreakable. Here's what I want to know. Have you ever been in a situation where simple, robust systems saved the day while complex technology failed? What traditional techniques do you think could solve modern problems? And honestly, would you rather trust your life to a smart home system or a building designed by people who knew that failure meant death? Drop your thoughts in the comments. I read every single one. If this made you see primitive technology in a completely new light, smash that like button and subscribe because we're just getting started uncovering ancient innovations that put modern engineering to shame.